It's perfect layout for someone to very corrupt. Go ahead, Ron.
Hi, everybody. I want to thank Tom for inviting me to talk about our research. Basically, developing and evaluating in the field intelligent spray systems in Oregon nursery production. This is actually a multi-state, multi-agency research project funded by the Specialty Crops Research Initiative. It's led by Dr. Hepping Zhu, who is our lead scientist, and he's with USDA ARS at the Application Technology Research Unit in Worcester, Ohio. In addition to the scientists at USDA, faculty at Oregon State University, the Ohio State University, and the University of Tennessee are all working on this project. As you can see, there are a lot of names in that title. There are 11 PIs, the principal investigators on this project. It's very multidisciplined. A lot of pathologists, horticulturists, entomologists, obviously ag engineers, economists as well. In Oregon, we've had the opportunity to work with two prototypes using intelligent spray technology. Our first prototype that we worked with was a modified GK Tracker TR4 over the tree row sprayer. So this is a hydraulic boom sprayer. It's got a 30-foot long boom with 6 bays with drop-down nozzle systems in it. And what we did was retrofit half of the GK with the intelligent spray systems technology. The technology has a few different components to it, but one of the most basic aspects of it is that we're using sensors to detect the presence, the height, the shape, width of the plants in the tree row in real time as the sprayer is going down the tree row. And that information is sent to a signal analyzer variable rate controller in a microprocessor unit, which signals the solenoid valves to change the flow of the solute in the pesticide tank, or nutrients if you use those, to the nozzles. So each one of the nozzles is individually operated based on that information sent from the sensor. With the first trial with the hydraulic sprayer, we had ultrasonic sensors. In this case, they're bouncing sound off of the plants and using that information. So the theory here is that you're going to turn off nozzles or reduce the flow when there isn't a plant target there. The thought is that we can reduce the volume of pesticides we apply by not spraying the empty spaces so much. One of the things we are doing with these sprayers in the 3 different states, Tennessee, Ohio, and Oregon, is looking at efficacy. We were the only ones looking at this particular sprayer type and the ultrasonic sensors. So we really wanted to do a good job with it. We took what is a common disease, powdery mildew, and Norway maples, and we also wanted an insect with each of our trials to assess the efficacy of the sprayer, because that's why you use a sprayer. If you're not killing bugs, it's not doing much good out there. So we worked in commercial nurseries. In this case, we worked up in Boring, Oregon, with this sprayer with J. Frank Schmidt and Sons, Shade Tree Nursery up there. And with the Norway maples and the powdery mildew, we applied 3 applications of fungicides. On the conventional system, there were 2 separate tanks on that sprayer, which made it easier for us to work with. It ended up that we applied 75 gallons per acre. With these intelligent sprayer technology, 30 gallons per acre were applied. This just gives you a feel for what we were looking at. We did a visual assessment. We did a ranking system that we could just do in the field. On the top there, you can see this was our 0. We looked at the 5 top leaves that were fully unfolded, so we didn't have sort of that historical powdery mildew stuff that was hard to judge. Our second rating was basically 1 to 25%. And then our third rating about 26 to 50%, and then everything over 50% was our top ranking. And we've had leaves that fully covered in good powdery mildew years. We also looked at aphids on oak, and in this case there was only one application that we assessed, and that was applied at 40 gallons per acre with a conventional system, and on the intelligent side only 20 gallons per acre were required. Oops. We ended up having 2 aphids on the oak. One, ironically, it ended up on the top and one on the bottom of the leaves, which is kind of nice when you're doing a sprayer assessment. But ended up, we didn't really see a difference, but it was kind of a pretty little aphid on there. Oh, and basically what we saw when we analyzed the sampling results, we sampled weekly throughout the season that we were looking at these. We saw no significant difference in the control or management of those 2 pests. So we applied less than 50% of the pesticide volume and still achieved the same level of control. The other prototype that we've worked with is an air-assisted spray system. In this case, it uses a laser sensor, and that is really nice because along with the presence and height and width of the plants, it also can sense the density of the canopy. And again, that information is all sent to the microprocessor. There are 5 of these prototypes that have been developed. There's one here in Oregon, one in Tennessee, and there are 3 up in Ohio, 2 at commercial nurseries up there. We actually were slowed down a little with this project because we had a direct hit at the Application Technology Research Center up in Worcester from a tornado. It wiped out their entire building and our first prototype. So they, being engineers, immediately built 5 more of these things, and we've been able to test them out. These are built on a hardy base. And in the cab, there's an embedded computer with a touch screen. That allows the operator to see a lot of what's going on. You can see whether the nozzles are firing on either side here. And they can also add or change some of the parameters, how far the laser detects and that sort of thing. We wanted to make it something that growers could customize for their individual needs out there. It's all solid state wiring, color coded for ease of trying to work with it. The tower, this is kind of a tower configuration on the sprayer. It has 5 fingered nozzle systems on either side, so we end up with 40 nozzles and all individually operated. This is the laser. It's kind of diminutive. Again, it's a laser, but you can't really see it with the eye, although sometimes with a high enough speed camera you can pick up the activity of the laser. Right above it there's a little fan to blow off any dust. That was a problem in early prototypes they had in California where dust just constantly covered the lasers and they couldn't sense things. This particular laser senses out 30 meters on either side of the sprayer in a 270-degree radius. We're not interested so much in putting, we're not doing herbicides with this type of sprayer, more fungicides, insecticides, and people put on foliar nutrients as well, as I mentioned. This is what the information looks like when it's basically it's sent to the signal analyzer and variable rate controller, so you can really picture the plant as it goes by. That information, as I mentioned, goes to the microprocessor unit. And that is sent to a multi-channel system. So there are 40 different solenoid valves that are on this particular sprayer. It is an air assist, so here is the fan, a shot of the fan on here, and the velocity of the air that is at the nozzle when it's atomized is about 150 miles per hour. It does drop off fairly rapidly within the first few feet. You see quite a drop, so we don't tend to see the big plumes of spray going out the top that you see with more jets of air. Almost everything on the sprayer is off the shelf, more or less. manufacturers will have access to this type of equipment. They really didn't customize too many things other than the signal analyzer software. In general, it's pretty accessible. They built these prototypes for $21,000, not counting labor, so it looks like it might come in an affordable range once private manufacturers become involved. And I think you'll have to get that for me. It's best to actually see this in action. So this is up at in Worcester at the USDA facility. Their plot out there. It was planted to have various types of plants so that you could see it firing when there's a target and then turning off those nozzles as it goes down the road. So you'll see at the end there's some shorter shrubs that they have, and you shouldn't see too many of the upper nozzles firing. This laser sensor can detect about a 1/4 inch wide. We tested it at the we tested it at North Willamette going down one of our caneberry breeding plots, and there was a big blank where something had been pulled out, and they were just posts and 2 wires. And we saw it go down and fire at the post, but the operator inside, again, you can look at the PC, the screen there, he said, no, there were 2 nozzles on the whole time hitting the wires as it went down. So it gives you an idea of the sensitivity of that. It also has, one more video, a pulsing system. Oh, it doesn't look like it. Pulling that one up.
Maybe try it out. You want to plug in from the other?
Yeah, do you have that other video that shows? Perfect, that shows runs. It also has a pulse width modulator. And you can see this is slow motion, but you can see, so it's pulsing as it goes down the row. That also helps to reduce the overall volume of the pesticide solution applied, while still giving us pretty good coverage out there. Thank you. And so one of the things they did in very controlled studies up in Worcester was look at the spray loss on the ground, comparing the intelligent sprayer to a conventional air blast sprayer. And what they saw was that they reduced spray loss on the ground by 68 to 93%. You get the biggest savings in the early season when you have less canopy, more empty space that you're spraying, and that's pretty dramatic. They also looked at spray loss between the tree canopies, and that was reduced by 40 to 87%. So we're doing a really good job with this sprayer reducing drift, both potentially onto the ground and in the air. We looked at this one in the same way, wanting to look at insects and diseases. In this case, with this sprayer, we looked at Pacific Coast pear rust, which is a rust that moves between cedars and plants in the pear family. Anybody working with service berries out there, Amelanchier, you might also recognize that rust on those. In this case, we counted lesions. We also looked at honey locust pod gall midge, which is a little midge that causes fold galls on honey locust leaves or the leaflets. And it can basically pod the entire leaflet up, so it doesn't even look like a leaf anymore. And we looked at the powdery mildew on the red maples again. This is Adriana, our nursery intern that year, and Derek Wells, who's our technician working on the project, and that gives you a feel for what our plots look like. Nurseries are always a little hard to work in. We don't have homogeneity. It's very diverse in there, so finding plots and matching them with separation so we don't have drift is always a challenge. But overall, our results showed, again, no significant difference in the management of the pests that we looked at, either the powdery mildew or on the insects or rust. And we compared the conventional air blast sprayer, in this case using BMPs. By that I meant that he turned off the upper nozzles that weren't aimed at plants and stopped the spray at the end of the rows. So that's kind of our BMPs for the conventional. To the intelligent sprayer, we saw a 55% reduction in volume in the Norway plots. Again, we did that same comparison in the 2-year paired plots with the Rust and saw a 54% reduction. And then just comparing the intelligent sprayer with the intelligence turned off or disabled, more or less it would be just a continuous flow, all the nozzles open. We saw a 76% reduction in the volume applied with the honey locust piebald midge and the honey locust plots. In the pear plots, we saw a 74% reduction in the volume with the pear rust. In 2014, again, we looked at pear rust, in this case on 3-year jack pears, comparing the intelligent sprayer again to the air blast using BMPs. And that's what our air blast sprayer looks like there. I don't know if you can see that real well, but kind of a small shot there. And in that case, the plots weren't exactly identical, but they served our purpose. So this is one long tree row in one case and 2 rows here. Again, just presence-absence sampling of this rust out there on a weekly basis. We also looked at sawfly on mazard cherry trees, and that was a bigger plot for us, so we were able to compare the intelligence sprayer with and without the sensor and intelligence working. More or less the non-intelligent is what we call it. And then the air blast sprayer, again using BMPs, and very rare for a nursery, we had an untreated control. And in this case, again, we were out on a weekly basis. This is what our plot looked like in the early season. Again, the plants are very tiny, so you have to have a sprayer that can hit the liner-sized trees when they're that small. And this pest comes up at the base. It pupates in the soil and comes up at the bottom leaves, so you really have to get that coverage at the lower down. And I'm not sure if it shows up in this room, but those trees get very high, about 8 to 10 feet by the end of the season. So there's a pretty dramatic change in the canopy, the volume of plants actually out there that these guys try to treat. And again, the sawfly is a typical sort of sawfly damage. They come on and they skeletonize the leaves, usually starting from the bottom of the plant up. And again, we did weekly sampling out there. There's a lot of numbers in this chart, but basically what we saw with the rust was, again, no significant difference in the rust ratings over the season, and the control was great. It looked good with the both the treatments, but again, we saw a 60% reduction in the volume of spray applied for the rust. With the sawfly, again, no significant difference in the management of the sawflies. In this case, comparing the air blast with the intelligent sprayer, we saw a 34% reduction in the spray volume. And then comparing the intelligent sprayer with and without the technology on, more or less, again, that continuous spray out of all the nozzles, we saw a 54% reduction. This just gives you kind of a visual of what that sawfly plot looked like, which is nice because we could actually show that here's our control. We did have pressure out there. And when once we sprayed, things really knocked down. So we were seeing good activity of the sprayers out there. I think we were in between. We had the August generation come on, and this was the earlier generation. I think things were mostly in the soil at that point in time. We also looked at this is just the change in application rates. Again, a visual of that, so you can see a pretty dramatic reduction, particularly with the pear rust. And we've done preliminary economics looking at the cost of the pesticides. And in the case of the pear, we saw a 58% reduction in the cost of the program to control the rust. And we saw 32.5% reduction comparing the intelligent sprayer to the air blast, and a 53% with the intelligent sprayer with and without the nozzles fully on or variable. What we didn't look at in the economic analysis was things like fuel and maybe more importantly to all of you, labor. the thing that the growers I work with who has this prototype at the nursery, this was at Hans Nelson Nursery in Boring. Clint there said he was just amazed when I told him it would go farther than normal once he got things going with that sprayer. And so the first time he ran it out, he filled up his tank, and he could not figure out enough places to spray because that one tank would normally be 1 acre for him, and it was going 3, 4, 5 acres for him whenever he went out. So he doesn't have to, this is a very relatively smaller nursery. 1, 2 people maybe at most do all the spraying at actually 2 nurseries they have. So time management is critical for these guys, and not having to go and remix another tank is huge. The time savings is just wonderful for them. And obviously that's a big issue with labor. So this is a shot of our team, part of our team up here in Oregon, and our team down in, or up in Ohio, who are probably standing in snow right now. That was what I got to do on my one sabbatical I've ever taken at Oregon State. I went to Ohio in January, so it was 0 degrees there, and snow, and everything's done in a warehouse that time of year. So it makes me appreciate our weather here for sure. And I think, again, we've had great cooperation from our nurseries here in Tennessee and Ohio, and appreciate the funding. We just finished the tail end of the 5-year SCRI, kind of trying to move to that next level. We've had a lot of interest with this sprayer. GK has been interested in licensing the technology, so we're hoping to help them surf their way through that with USDA. We also hope to start bringing the sprayer into other systems. I think in particular in tree fruit, particularly intensive high-density rows that we're seeing go in some areas. We think it'll work very well with viticulture. They've already run it through vineyards, and it does what you'd expect it to do. And there may be applications in small fruit. Again, these are crops that are anything that's deciduous and has a bunch of empty space is going to be using too many pesticides probably for what is needed. A lot of what I liked about this team was that before they even built these sprayers, they had the Ohio growers at 50 gallons per acre versus the standard 100 gallons per acre. And that's because they're so well set up at this research unit that they can document what's going on when you apply that much, and they basically were washing their active off their plant. And so they can, they have high-speed laser analysis of droplets. They do quite a bit of backup verification on everything they do up there, using usually 2 methods to assess what's going on out there in the field. And so they definitely show folks what is hitting the plant is usually too much. And of course, we don't want to spray those empty spaces. So the good news is when we've shown environmental regulators this type of technology in the field, I've actually had a couple of them come up and tell me they think they may have to change the risk models for the chemicals. The safety, how much is in that safety cup from the Food Quality Protection Act, if this is adopted. So we like this because we think that it might be a way of allowing growers to have a wider range of chemistry still available and reducing the impact of it moving, the chemistries moving into our water, for instance, which is pretty highly visible nowadays. Well, that's pretty much an overview. If you have any questions,
Questions, Rob? Thanks, Rob.